All right, today we're looking at the perpendicular bisector locus, and it's in the form, you know that it's perpendicular bisector when you see z minus z1 modulus of equals z minus z2 modulus of. So here's an example, z minus that equals z minus that. The trick here is you got to change that into z minus z1 because it's not at the moment. So that's z minus 1 minus 3i equals z minus 5 minus 7i. And so that's your Z1, that's your Z2. So if you look at it from the 2-unit maths or maths advanced year 11 stuff, coordinate geometry, it's very straightforward. The point is 1, negative 3. That's point Z1. And then it's 5, negative 7, which is somewhere here. Of course, it's not to scale. Because you know that it's perpendicular bisector, that's exactly what it is. So basically, you want a line that is 90 degrees to that, bisect that into 2, and you want to find, well, that's basically is the locus. That's what it looks like, literally. Now, to find the actual Cartesian equation of it, that's the hardest thing. But to draw it, it's damn easy. Draw Z1, draw Z2, somewhat to scale, by the way, too. And then draw a line that is 90 degrees to that, and then cut it into half. Now, to find the Cartesian equation, which is the hardest thing, like I said, you look at it, you treat it like points. So this is 5, negative 7. This is 1, negative 3. Now, in Maths Advanced, to find the midpoint, so this point, let's call it M. The midpoint here, I believe, is you add the x values together, you divide by 2, you get 3. You add the y value together, you divide by 2, I believe it's negative 5. So the midpoint is 3, negative 5. You find the gradient of the interval here. So M1 is just 2-point, gradient formula, which is minus 3 minus 7 on 1 minus 5, which I believe is 4 on negative 4. So I rigged this. So this is negative 1. So this is really easy, nice gradient. So therefore, M2 must be 1 because, in 2-unit, M1, M2 equals minus 1. So M2 equals minus 1 on M1. And since M1 is minus 1, so M2 must be 1. Too easy. And then you just use the gradient point formula, which is y minus y1 equals M2 in this case, x minus x1. So y minus, the midpoint here is 3, negative 5, so minus 5. The gradient is 1. How good is that? And then it's x minus 3, so y plus 5 equals x minus 3. So it's just y equals x minus 8. So which means it's going to cut this at minus 8, and it's going to cut this at also 8, yeah? And that's, I swear, is the Cartesian equation of that very complex-looking equation, which is a perpendicular bisector equation. That's where I'll stop from there.